June 18, 1944. The hedgerow country of Normandy, France. Captain Robert Mallory stood at the edge of what had been a wheat field 12 hours earlier and watched his breath fog in the predawn cold. Through the darkness, he could hear the grinding of bulldozers, the metallic clang of steel mesh being unrolled, the shouted orders of sergeants, pushing exhausted men past the point where exhaustion should have stopped them. Somewhere beyond the tree line, German artillery was finding its range. Shells landed close enough that Mallory could feel the concussions through the soles of his boots. His engineering battalion had been given an assignment that violated every principle of military construction he had learned at West Point. Build a fully operational airstrip capable of handling P-47 Thunderbolt fighters in 48 hours. Not in a week, not with proper surveying and foundation preparation. 48 hours from bare earth to operational runway. The German Luftwaffe had been told such a thing was technically impossible. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. The mathematics of impossibility had been explained to Mallory 3 days earlier in a command tent outside Carentan. Colonel James Whittaker, the chief engineer for the 9th Air Force, had spread reconnaissance photographs across a folding table and pointed to a section of farmland approximately 6 kilometers inland from Utah Beach. The photographs showed open fields bordered by the infamous Norman hedgerows, those ancient earthen walls topped with thorny vegetation that had turned the French countryside into a defender's paradise and an attacker's nightmare. "We need a forward airstrip here within 72 hours of securing the perimeter," Whittaker had said, his finger tapping the photograph. "Preferably sooner. The fighter groups are operating from England and they're burning half their fuel just getting to the combat zone. We're losing air superiority over our own beachhead because our planes can't loiter long enough to provide effective cover." Mallory had studied the photographs with growing disbelief. The proposed site was barely 3 kilometers from the front lines. German forces still held the high ground to the south. Enemy artillery could range the entire area. The fields were soft from spring rains. There were no existing roads capable of supporting heavy equipment. The standard construction timeline for a forward airstrip, even under ideal conditions, was 2 weeks minimum. That assumed stable ground, secure perimeter, and uninterrupted work. The colonel was asking for something that would require either a miracle or a completely new approach to military engineering. "How long do we actually have, sir?" Mallory had asked. Whittaker's expression had been grim. "The Germans are moving their fighter squadrons forward. Intelligence estimates they'll have 3 full Jagdstaffel operating from improvised strips within 5 days. If we don't match them, they'll own the sky over the beachhead. You have 48 hours from the moment the infantry secures that field. 48 hours to build 3,000 feet of runway capable of handling fully loaded P-47s taking off with external ordnance." The historical context made the request even more daunting. Military airfield construction in 1944 followed procedures that had been refined over decades. Standard practice required surveying teams to map the terrain and test soil composition. Engineers would then excavate to reach stable subsoil, compact the foundation in layers, and construct drainage systems to prevent water accumulation. The runway surface itself consisted of either concrete, which required time to cure, or steel matting laid over prepared substrate. The entire process involved thousands of man-hours and assumed working conditions, free from enemy interference. What Colonel Whittaker was requesting amounted to battlefield improvisation on a scale the Army Corps of Engineers had never attempted. Mallory commanded the 834th Engineer Aviation Battalion, a unit that had formed in Louisiana in 1943 and had spent the past year training for exactly this kind of rapid construction. His battalion consisted of 4 companies totaling approximately 900 men, most of them in their early 20s. most of them from rural backgrounds where they had operated heavy machinery on farms and construction sites before the war. They had trained with the new pierced steel planking system, a revolutionary construction method that the Army had developed specifically for rapid airfield deployment. The PSP system consisted of interlocking steel plates, each measuring 10 feet by 15 inches and weighing approximately 70 pounds. The plates featured circular perforations that reduced weight while maintaining structural integrity. Teeth on the long edges allowed the plates to connect, creating a continuous surface that could be laid directly over compacted earth. The 834th had practiced PSP installation at airfields in Tennessee and Virginia, achieving respectable construction times under training conditions. Their best performance had been laying 1,200 feet of runway in 72 hours, working in shifts with no enemy interference and ideal weather. What Whitaker was asking them to do was more than double that length in less time while under artillery fire. The theoretical maximum laying rate, according to the technical manuals, was approximately 40 feet of runway per hour per laying team. To achieve 3,000 feet in 48 hours would require sustained speeds well above what the manuals considered possible. Captain Mallory was 31 years old, older than most company-grade officers because he had spent 4 years working for a construction firm in Chicago before receiving his commission. He had supervised the building of warehouse foundations and highway underpasses, projects where speed mattered but not like this, where lives hung in the balance of every hour gained or lost. His executive officer, Lieutenant Thomas Brennan, was a 24-year-old mining engineer from Pennsylvania who understood rock and soil mechanics better than anyone Mallory had ever met. His operations officer, Lieutenant Michael Chen, was a second-generation Chinese-American from San Francisco who had a gift for logistics that bordered on supernatural. Together, they had spent the 3 days since receiving their orders planning an operation that rewrote the engineering manual. The invasion of Normandy had commenced on June 6, 1944. Allied forces had established beachheads along 50 miles of French coast, but the advance inland had been slower and bloodier than planners had anticipated. The hedgerow country behind the beaches favored defenders who could establish strong points at every field boundary and turn every farm into a fortress. American casualties in the first 2 weeks had exceeded 10,000. Air support was critical to breaking the German defensive lines, but the tactical air forces were operating at a severe disadvantage. American fighters based in England had only enough fuel to spend 20 to 30 minutes over the battlefield before needing to return for refueling. German fighters operating from bases in France could loiter much longer, choosing when to engage and when to withdraw. The solution was forward airstrips, but building them under combat conditions had proven extraordinarily difficult. Several attempts had been made to establish strips near the beaches, but German artillery had repeatedly disrupted construction. The strip that Mallory's battalion was assigned to build was designated as A-10, the 10th Advanced Landing Ground in the Normandy operational area. Its location had been chosen because a recent American advance had pushed the front line far enough south to create a narrow zone that was beyond the range of most German artillery, while still close enough to the combat zone to give American fighters meaningful loiter time. On June 15, the 2nd Infantry Division had secured the fields designated for A-10 after 2 days of brutal fighting through the hedgerows. They had pushed German forces back approximately 5 kilometers and established a defensive perimeter that was fragile but holding. Mallory and an advance party had moved forward that same afternoon to conduct a hasty reconnaissance. What they found was worse than the photographs had suggested. The primary field selected for the runway was indeed flat, but the soil was Norman clay, dense and heavy when wet, but prone to developing cracks when dry. Recent rains had left the ground saturated. When Mallory pushed a surveying rod into the earth, it sank 6 inches before hitting resistance. Water pooled in the hole when he withdrew the rod. Lieutenant Brennan had knelt and examined the soil with the intensity of a prospector examining ore. "This is going to settle under load," he said quietly. "If we just lay matting on top of this, The first few planes will be fine, but after a dozen landings, the whole surface will start to develop depressions. We need at least 8 inches of crushed stone as a base course, properly compacted." Mallory had nodded, already running calculations in his head. 8 inches of crushed stone over 3,000 feet of runway meant approximately 3,000 cubic yards of aggregate. That quantity would require nearly 200 truckloads. They would need to establish a quarry operation, haul the stone to the site, spread it, and compact it before they could even begin laying the steel matting. The timeline was impossible. Lieutenant Chen had been studying the surrounding landscape through binoculars. "There's a stone quarry approximately 4 kilometers northwest," he reported. "I can see the chalk faces from here. If we can get bulldozers there and start excavating immediately, we might be able to establish a conveyor system of dump trucks running continuously." Mallory had made his decision in that moment. The standard engineering approach would fail, because there was no time for standard procedures. They would have to work in parallel rather than in sequence, starting multiple tasks simultaneously, and accepting risks that would normally be unthinkable. They would excavate the quarry while clearing the runway site. They would begin hauling and spreading stone before the full excavation was complete. They would lay steel matting over sections of runway while other sections were still being compacted. Every phase would overlap, every crew would work without break, and the entire operation would depend on coordination measured in minutes rather than hours. The battalion had moved forward on the night of June 16. 900 men, 40 bulldozers, 30 dump trucks, 20 graders, and enough pierced steel planking to surface 3,000 feet of runway. The convoy had moved slowly through the darkness, navigating roads that were still being cleared of debris from recent fighting. They had passed columns of infantry, moving up to the front, supply trucks hauling ammunition, ambulances carrying wounded back to the beaches. The sounds of artillery fire had been constant, a rolling thunder that never quite faded.
Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story.
Mallory had ridden in the lead vehicle studying maps by flashlight and refining the plan that would have to work perfectly because there was no margin for error. They had reached the designated site at 0300 hours on June 17. Mallory had assembled his company commanders in the darkness and given them their assignments with the precision of a surgeon describing a complex operation. A company would clear the runway site, removing vegetation and surface debris. B Company would establish the quarry operation and begin hauling stone. B Company would grade and compact the stone as it arrived. B Company would lay the pierced steel planking as soon as each section of runway was prepared. The entire operation would run 24 hours a day in 3 8-hour shifts. No breaks except for meals eaten at workstations. No delays except for direct enemy action. The work had begun at first light on June 17. Captain Theodore Walsh, commanding a company, had put his bulldozers to work clearing the hedgerows that bordered the designated runway site. The hedgerows were more formidable than they appeared, centuries-old earthen banks reinforced by root systems that extended 10 feet deep. The bulldozers had attacked them with grinding determination, pushing through soil and stone and tangled vegetation. Each hedgerow took nearly 2 hours to breach, and there were 8 of them crossing the runway path. By noon on the first day, they had cleared only half the site. The quarry operation had begun simultaneously. Captain Frank Morrison, commanding B Company, had taken his equipment to the quarry site Lieutenant Chen had identified. The quarry was an old chalk excavation that had provided building stone for local villages for generations. German forces had used it as a supply dump before their recent withdrawal, and Morrison's men had found ammunition crates and fuel drums scattered among the chalk faces. They had cleared the German materials quickly, then set the bulldozers to work excavating fresh stone. The chalk fractured easily under the bulldozer blades, breaking into pieces ranging from fist-sized chunks to fine powder. It was not ideal aggregate material, but it was available immediately and in unlimited quantity. The first dump trucks had begun hauling stone to the runway site by 0900 hours. Each truck carried approximately 15 cubic yards of material. The round trip from quarry to runway and back took 40 minutes. To maintain the required flow of aggregate, Morrison had established a rotation where trucks departed at precisely timed intervals. The operation had resembled an industrial assembly line transplanted into a combat zone. Bulldozers excavating, trucks loading, drivers racing along improvised roads, stone piling up at the runway site faster than the grading crews could spread it. Lieutenant Brennan had commanded the grading and compaction operation with obsessive attention to detail. Each truck had dumped its load at designated points along the runway path. Bulldozers had then spread the stone in layers approximately 4 inches deep. Graders had followed, smoothing the surface to precise specifications. Finally, heavy rollers had compacted the stone, making dozens of passes until the aggregate was compressed into a stable mat. Brennan had personally inspected every 100 feet of completed base course, measuring the depth and testing the compaction with steel probes that revealed any soft spots. He had rejected 3 sections that did not meet his standards, ordering them torn up and rebuilt despite the time lost. The German response had been slower than Mallory had feared, but more persistent than he had hoped. On the afternoon of June 17, enemy artillery had begun ranging fire on the construction site. The shells had landed randomly at first, explosions that sent geysers of dirt skyward but caused no casualties. By evening, the German spotters had refined their aim. A salvo had landed directly among B Company's bulldozers at the quarry, destroying one machine and killing its operator. Another salvo had struck near the runway site, wounding 4 men and scattering a pile of steel matting. Mallory had ordered the work to continue. Stopping would mean failure, and failure would mean American pilots dying in the skies over Normandy, because they ran out of fuel before they could return to England. The first night had been the worst. Working in darkness with only minimal lighting, the battalion had struggled to maintain the pace they had achieved during daylight. Bulldozer operators had difficulty judging distances and depths. Truck drivers had run off the improvised roads, requiring recovery operations that consumed precious time. The grading crews had found it nearly impossible to achieve the precision Brennan demanded when they could barely see the surface they were working. Mallory had walked the entire length of the construction site repeatedly, pushing men who were already beyond exhaustion, making decisions about acceptable quality versus sufficient speed. By dawn on June 18, they had completed approximately 1,200 feet of base course. The pierced steel planking crews from D Company, commanded by Captain Harold Jensen, had begun laying matting over the first completed sections. The PSP system worked through sheer simplicity. The steel plates interlocked through a tooth and slot connection that required no tools. A crew of 12 men could lift a plate, carry it to position, drop it into place, and move to the next plate in approximately 90 seconds. The difficulty was maintaining that pace for hour after hour, plate after plate, fighting fatigue and German artillery, and the knowledge that every minute of delay meant American fighters would remain grounded. Jensen had organized his men into 4 laying teams, each responsible for 1 parallel row of matting. The teams had worked in a synchronized rhythm that had resembled a military drill. 4 men would lift a plate from the supply stack. They would carry it forward to the runway edge. They would drop it into position, ensuring the connecting teeth properly engaged with the previous plate. 2 men would follow with hammers, driving pins through the connection points to prevent lateral shifting. The team would then return to the supply stack and repeat the process. Each team had laid approximately 1 plate per minute during the peak periods, a rate that the technical manuals had stated was physically impossible to sustain. The supply operation had been as critical as the construction work itself. Lieutenant Chen had established a logistics system that brought materials forward in a continuous flow that matched the consumption rate exactly. Trucks hauling stone from the quarry had arrived at intervals calculated to keep the grading crews constantly supplied without creating bottlenecks. Flatbed trailers carrying bundles of pierced steel planking had delivered new material to the laying teams at precisely the moment the previous bundle was exhausted. Chen had positioned himself at a command post with radio contact to every work section, adjusting delivery schedules in real time based on progress reports that came in every 15 minutes. His ability to visualize the entire operation and identify potential delays before they occurred had been the invisible force that kept 900 men and dozens of machines working in harmony. The German artillery had intensified on the second day. Observers on the high ground to the south had identified the construction site as a target of strategic importance. Salvos had begun landing at regular intervals, forcing the construction crews to take cover in hastily dug slit trenches. Each barrage had cost approximately 15 minutes of work time. After the fourth barrage, Mallory had made a decision that he knew might result in casualties, but that was necessary to maintain the schedule. He had ordered the crews to continue working through the artillery fire unless shells were landing within 100 yards of their position. The men had complied without complaint, understanding that the mission required accepting risks that peacetime construction would never tolerate. By noon on June 18th, the runway was approximately 60% complete. 1,800 feet of pierced steel planking had been laid and pinned. The grading crews were working 500 feet ahead of the laying teams, preparing the base course that would receive the next sections of matting. The quarry operation was running continuously, having delivered nearly 2,000 cubic yards of aggregate. The battalion had been working for 33 hours with only brief pauses for meals. Men were operating on adrenaline and willpower, their movements mechanical from exhaustion, but their pace sustained by the knowledge that pilots were depending on them. The critical moment had come at 1400 hours on June 18th. A German artillery barrage had landed directly on the quarry operation, destroying 2 dump trucks and killing 3 men. Captain Morrison had radioed Mallory with the news that his hauling capacity had been reduced by 20%. The timeline, already stretched to the breaking point, was about to snap. Mallory had stood at the runway site, watching his men work, doing the mathematics in his head. They needed approximately 600 more cubic yards of stone to complete the base course. With 2 trucks out of service, the delivery rate would drop below the threshold needed to keep the grading crews working continuously. Any gap in the supply chain would create idle time that they could not afford. Lieutenant Brennan had appeared beside him, reading the situation with the instinct of an engineer who understood logistics as well as construction. "We can thin the base course in the final 500 feet, he had said quietly. "Drop from 8 inches to 6. It'll be marginal for long-term durability, but it should hold up for initial operations." Mallory had nodded, knowing Brennan was right but hating the compromise. They had built the first 2,500 feet to standards that would last for months of intensive use. The final 500 feet would be adequate for the immediate mission, but would require rebuilding eventually. It was the kind of calculated risk that separated combat engineering from peacetime construction. The work had continued through the afternoon and into the evening. By 2000 hours, 24 hours before the 8-hour deadline, they had laid 2,700 feet of matting. 300 feet remained. The end was visible, close enough to taste, but the men were operating at the absolute edge of human endurance. Mallory had walked among the crews, speaking quietly to men whose eyes were hollow from exhaustion, whose hands were bleeding through work gloves worn to tatters, whose bodies moved through muscle memory because conscious thought was becoming difficult. The final push had begun at 2,200 hours. Captain Jensen had assembled his laying crews and told them simply that they would finish tonight, that there would be no sleep until the runway was complete. The men had returned to work without complaint. Plate after plate had been lifted, carried, positioned, pinned. The rhythm had slowed slightly as exhaustion took its toll, but it had never stopped. The supply crews had kept the steel matting flowing forward. The grading crews had completed the final sections of base course, Brennan personally inspecting each foot to ensure it met minimum standards. At 0147 hours, on June 19, 46 hours and 47 minutes after construction had begun, the final plate of pierced steel planking had been dropped into position. Captain Jensen had driven the last pin himself, hammering it through the connection point with methodical precision. When he had straightened up and looked back along the length of the runway, he had seen 3,000 feet of steel matting stretching into the darkness, a geometric ribbon of human determination that had not existed 2 days earlier. The runway was complete. Mallory had walked the entire length of the runway as his men had assembled at the far end. 900 men, most of them sitting or lying on the ground, too exhausted to stand. He had wanted to give them a speech, something that would capture the magnitude of what they had accomplished, but the words had failed him. Instead, he had simply said, "Thank you, you just changed the war." Then he had walked to his tent and slept for the first time in 48 hours. The test of the runway had come at dawn. A single P-47 Thunderbolt from the 365th Fighter Group had approached A-10 for the first landing. Major William Hartley, the pilot, had circled the field twice, examining the runway from the air. The pierced steel matting had been clearly visible, a lighter strip against the darker earth of the surrounding fields. Hartley had dropped his landing gear, reduced throttle, and brought his fighter down in a textbook approach. The Thunderbolt's main wheels had touched the steel matting at approximately 0630 hours. The runway had held without flexing or settling. Hartley had rolled to a stop, pivoted his fighter, and taxied back to the far end. He had then applied full throttle and launched himself back into the air, the Thunderbolt's radial engine roaring as it climbed away from the field that had not existed 3 days earlier. Within 2 hours, the first full squadron of P-47s had arrived at A-10. 12 fighters had landed, refueled from trucks that had been positioned alongside the runway, and taken off again to provide air cover over the American lines. The operational impact had been immediate and dramatic. American fighters that had previously been able to spend only 20 minutes over the battlefield could now loiter for nearly 2 hours. German aircraft that had been harassing American ground forces found themselves confronted by fighters that could engage, disengage, refuel at A-10, and return to the battle in less than 30 minutes. The balance of air superiority began to shift within hours of the runway becoming operational. The German reaction to the sudden appearance of A-10 had been swift and focused. Luftwaffe reconnaissance flights had photographed the new airstrip on June 19. The photographs had been rushed to the headquarters of Luftflotte 3, the air fleet responsible for operations over France. The German analysts who had examined the images had been stunned by what they showed. Intelligence had reported that Allied engineering battalions required a minimum of 2 weeks to construct a forward airfield. The photographs showed a fully operational runway that had not existed 4 days earlier. The implications were deeply troubling for German defensive planning. If the Americans could build airfields this quickly, the Luftwaffe's strategy of trading space for time was obsolete. German air attacks on A-10 had begun within 24 hours of its completion. Focke-Wulf FW-190 fighters had attempted low-level strafing runs, but American anti-aircraft batteries, positioned around the perimeter, had driven them off. The Germans had then tried night bombing raids, using Junkers Jo-88 medium bombers. The bombs had cratered the surrounding fields, but had struck the runway itself only twice. The pierced steel matting had proven remarkably resistant to bomb damage. Where concrete runways developed spiderweb cracks that could disable entire sections, The interlocking steel plates simply absorbed impact. Damaged plates could be replaced individually in less than 30 minutes, a repair time that made the runway nearly impossible to put permanently out of commission. The strategic calculations began shifting within 72 hours of the runway's completion. Major General Elwood Quesada, commanding the 9th Tactical Air Command, had visited A-10 on June 21 and witnessed something that transformed his understanding of mobile air operations. 16 P-47 Thunderbolts were operating from the strip in continuous rotation. Pilots were landing, refueling in under 10 minutes, rearming from supply trucks positioned beside the runway, and launching back into combat. The turnaround time from landing to takeoff had dropped from the 2 hours required when fighters operated from England to less than 15 minutes when operating from forward strips like A-10. Quesada immediately ordered the construction of 6 additional forward airstrips using the same rapid construction methods that Mallory's battalion had demonstrated. The German High Command received detailed intelligence reports about A-10 by June 23. General Oberst Hugo Sperl, commanding Luftwaffe 3, had convened an emergency meeting of his staff officers to assess the implications. The briefing officer had presented reconnaissance photographs showing not just A-10 but 3 other American airstrips that had been constructed using identical methods in less than a week. Sperl had studied the photographs in silence, then asked the question that would define German tactical aviation strategy for the remainder of the Normandy campaign. How do we defend against an enemy who can build airfields faster than we can destroy them? No one in the room had an adequate answer. The traditional Luftwaffe doctrine of targeting enemy airfields assumed those airfields were permanent installations that required weeks to construct and could be disabled for days with successful bombing raids. The Americans had invalidated that assumption. Captain Robert Mallory received the Distinguished Service Medal in a ceremony at 1st Army Headquarters on July 2. Lieutenant General Omar Bradley had personally presented the award, telling Mallory that his battalion's work had changed the operational parameters of the air war over Normandy. Bradley had then asked Mallory to prepare a training program that would teach rapid runway construction techniques to every engineering battalion in the European theater. Within 2 months, Mallory found himself back in England, conducting week-long courses for engineer officers who would apply his methods to airfield construction across France and eventually into Germany itself. The human cost of the 48-hour construction marathon had extended beyond the 3 men killed during the artillery barrage. Medical officers examining the 834th Engineer Aviation Battalion in the week following the runway's completion had found that nearly 40% of the men were suffering from exhaustion-related conditions. Dehydration, muscle strain, and stress injuries were epidemic. 2 soldiers had collapsed from heat exhaustion despite the moderate June temperatures. Lieutenant Brennan had developed a tremor in his hands that persisted for 3 weeks. The battalion had been pulled off the line for 10 days of rest and reconstitution, during which Mallory had written commendation letters for 67 men whose performance had exceeded what he believed human beings were capable of sustaining. The technical innovations developed during the A-10 construction became standard practice across the Army Corps of Engineers. The parallel construction method, where multiple phases of work proceeded simultaneously rather than sequentially, reduced average airstrip construction time from 14 days to less than 4. The reduced depth base course that Brennan had implemented in the final sections proved adequate for tactical operations and was adopted as an acceptable standard for forward combat airstrips. The continuous supply system that Lieutenant Chen had orchestrated became the model for logistics planning in rapid construction scenarios. Engineering schools began teaching the A-10 methods within months of the runway's completion. The airstrip itself remained operational until October 1944, when Allied forces advanced far enough east that A-10 fell outside the effective range of the combat zone. During its 4 months of operation, more than 8,000 aircraft movements had been recorded at the field. P-47 squadrons operating from A-10 had flown over 3,000 combat sorties, destroying an estimated 200 German vehicles, 26 tanks, and shooting down 43 enemy aircraft. The fighter groups credited A-10 with enabling the close air support missions that had been critical to breaking through the German defensive lines during Operation Cobra in late July. Without the forward basing that A-10 and similar strips provided, American ground forces would have advanced far more slowly and at far higher cost. German officers interrogated after the war provided their assessment of the American rapid airfield construction capability. General Major Dietrich Peltz, who had commanded bomber operations against Allied targets in France, stated that the American ability to construct functional airstrips in under a week had been one of the most significant tactical surprises of the Normandy campaign. We had based our defensive planning on the assumption that destroying an Allied airfield would remove it from operation for at least several days, Peltz explained during post-war debriefing. When we discovered they could repair bomb damage in hours or build entirely new strips in days, we realized our interdiction strategy was obsolete. The psychological impact was severe. Our pilots understood they were fighting an enemy with effectively unlimited infrastructure. The 834th Engineer Aviation Battalion went on to construct 17 additional airstrips across France, Belgium, and Germany before the war ended in May 1945. None required the desperate speed of the A-10 construction, but each benefited from the techniques and procedures developed during those 48 hours in June 1944. Captain Mallory received promotion to major and eventually to lieutenant colonel, serving as chief engineer for the 9th Air Force during the final year of the war. Lieutenant Brennan survived the war and returned to Pennsylvania, where he applied his combat engineering experience to post-war highway construction. Lieutenant Chen remained in the Army after the war, eventually retiring as a colonel and becoming one of the first Asian American officers to reach senior rank in the Corps of Engineers. The pierced steel planking that had made the rapid construction possible became one of the most widely produced items of military equipment during the final year of the war. American factories manufactured over 2 million individual plates between June 1944 and May 1945. The system was used to construct over 300 forward airstrips in Europe and the Pacific, enabling tactical air operations that would have been impossible with conventional concrete runways. The engineering principles developed for PSP installation influenced post-war airport construction and eventually contributed to the development of modern modular runway systems still used for rapid deployment airfields. The final measure of A-10's significance came from the fighter pilots who operated from the strip. Captain James Morrison of the 365th Fighter Group, who had flown 42 combat missions from A-10 between June and September 1944, provided perhaps the most succinct assessment during a post-war interview. Every minute we saved by refueling at A-10 instead of flying back to England was a minute we could spend protecting our guys on the ground. The engineers who built that runway in 2 days gave us back hours of combat time every single day we operated from there. You can't calculate how many lives that saved, but it was a lot. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.